YouTube script, best elevator solutions for existing buildings. Hook adding an elevator to an existing building is very different from planning one for a new development. In a new building, the shaft pit, overhead clearance, machine room, structural loads, and access routes can all be designed from the beginning. In an existing building, those conditions are already fixed. You may have limited shaft space, a shallow pit, low overhead clearance, structural restrictions, utility, interference, or even historic architectural features that cannot easily be changed. So, what is the best elevator solution for an existing building? The answer depends on the building itself. 1. Start with the building, not the elevator. One of the biggest mistakes in retrofit projects is choosing the elevator system before evaluating the building. The first step should be a detailed site assessment. Important factors include available shaft space, pit depth, overhead clearance, structural capacity, building height, passenger traffic, door locations, installation access, maintenance access, and power supply. These conditions often determine which elevator solutions are actually practical. For existing buildings, customized engineering is often more important than simply choosing the newest elevator technology. 2. What if shaft space is limited? Limited shaft space is one of the most common retrofit challenges. A conventional elevator shaft needs room not only for the cabin, but also for guide rails, doors, structural supports, equipment, and maintenance access. If the available space is very small, possible solutions may include compact elevator shafts, customized cabin dimensions, alternative door configurations, or machine room-less systems. In some buildings, stairwells, storage areas, or external spaces may also provide possible installation locations. The goal is not simply to make the elevator as small as possible. System still needs to meet passenger, accessibility, safety, and maintenance requirements. 3. Shallow pit and low headroom solutions. Pit depth is another major challenge. Existing foundations, underground utilities, and structural slabs may make deep excavation difficult or expensive. In these situations, shallow pit elevator systems can reduce construction requirements. Low overhead clearance can create a similar problem at the top floor. Older buildings may not have enough space above the highest landing for a conventional elevator configuration. Machine room-less systems or specially configured traction elevators can sometimes help reduce overhead requirements. But the available dimensions should always be measured carefully before final equipment selection. 4. Which elevator type is suitable? There is no single elevator system that works for every existing building. A machine room-less or MR elevator can be a good option when there is no space for a traditional machine room. It is commonly considered for apartment buildings, offices, hotels, and other modernization projects. A traction elevator can provide smooth operation and good energy efficiency. It may be suitable for multi-floor buildings or projects with higher passenger demand. A hydraulic elevator may be practical for certain low-rise buildings, especially where specific overhead or structural conditions favor hydraulic technology. Platform lift can be useful when the main objective is accessibility rather than high passenger traffic. It is commonly considered for schools, public facilities, and some residential projects. For private homes, a compact home elevator may provide a better balance between accessibility, space efficiency, and daily convenience. The right elevator type depends on how the building is used. 5. Indoor or outdoor retrofit. Sometimes the most important decision is not hydraulic versus traction. It is whether the elevator should be installed inside or outside the building. Indoor elevator can integrate directly with the building and provide natural weather protection, but it may require more interior construction and reduce usable floor area. An outdoor elevator can preserve the existing interior layout and may reduce disruption inside the building. This can be especially useful when interior shaft space is limited. Outdoor installations require additional planning for weather protection, drainage, corrosion resistance, shaft structure, and FAA integration. For some existing buildings, an external steel or aluminum shaft can be a very practical solution. 6. Self-supporting elevator. Shaft structural limitations are another common challenge. An elevator introduces new loads into the building, so engineers need to evaluate foundations, floor slabs, anchoring points, and load transfer paths. If the existing structure cannot easily support a conventional shaft, a self-supporting shaft may be considered. Steel structure shafts provide strong structural performance and flexible fabrication. Aluminum alloy shafts can offer a lighter weight and corrosion-resistant alternative. Glass shaft configurations may also be used when visibility and architectural appearance are important. A self-supporting shaft can reduce dependence on the existing building structure and simplify some retrofit projects. 7. Different buildings need different solutions. The best solution also depends on the building type. For apartment buildings, MRL elevators are often considered because accessibility, passenger capacity, and space efficiency are important. For hotels, passenger elevators or panoramic elevators may be suitable, depending on traffic volume and architectural goals. For office buildings, traction and MRL systems can provide a good balance between efficiency and passenger performance. For historic buildings, preserving the original architecture may be one of the biggest priorities. External shafts or panoramic configurations can reduce disruption to the existing structure. For private homes, home elevators, compact traction systems, or platform lifts may be more practical, depending on available space and accessibility needs. 8. Modernization or complete replacement. Some existing buildings already have elevators. In that case, the question may be whether the system should be modernized or completely replaced. Modernization can involve upgrading controllers, traction machines, door operators, safety systems, or suspension components. This can improve ride quality, reliability, safety performance, and diagnostic capability. Complete replacement may be necessary when the existing system no longer meets safety requirements, spare parts are unavailable, capacity requirements have changed, or structural changes are needed. The decision should be based on the actual condition of the elevator, not just its age. Conclusion. So, what is the best elevator solution? For an existing building, there is no universal answer. An RL elevator may solve machine, room limitations. A traction elevator may provide better energy, efficiency, and performance for multi-floor buildings. A hydraulic elevator may be suitable for certain low-rise, retrofit conditions. A platform lift may work well when accessibility is the main objective. A compact home elevator may be more practical for a private residence, and when indoor space is extremely limited. An outdoor elevator with a self-supporting shaft may be the better solution. The most important principle is simple: start with the building, not the elevator. Evaluate the available shaft space, pit depth, overhead clearance, structural conditions, traffic requirements, installation access, maintenance access, and long-term operating needs first, then choose the elevator system that fits those conditions. For more details, read the full article. https://acnilift.com/best-elevator-solutions-for-existing-buildings/